this is John Whitaker for the Probability 1 class, and I wanted to post a video to correct something I said in our second class face-to-face meeting and answer in a hopefully better fashion a question that Chris Treen asked me. And so Chris was asking about how do you integrate a function of two variables over a region in the xy plane in terms of the order of integration and what factor that plays, how to set up the problem, I believe was his question. And when I tried to address that in an example for our second class meeting, I did not do a good job and said partially something incorrect. So here's the information, okay? Okay, so to integrate a joint PDF, okay, of two variables, normally we say x and y, over a region in the xy plane. Here's what we do. We pick an order of integration. For us, it's not going to matter what we pick, okay? That we're going to end up with the same answer regardless. It might be less difficult one order over another, but we pick an order of integration, and we're integrating with respect to x and y. But I'm going to say dv1 then dv2. So that's the way I'm going to write down that dv1 dv2. Okay, so that means that really the outer integral is with respect to v2 and the inner integral with respect to v1. Okay, the second thing we're going to do is then, as I said, the first integral listed, okay, has limits, okay, that are numbers. Okay, that's what we're having. Which are the smallest. So I say numbers, but they may be variables depending upon our situations, but they're quantities which are the smallest and biggest values of the variable v sub 2. The limits for the second integral, this is 2, the third comment is, the limits for the second integral, okay, are found by fixing a particular v2 value, okay, and seeing what is the smallest and biggest v1 values for that fixed v2 value. And that's what gives you your lower and upper limits of integration for that inner interval. Okay, so as an example, we were looking at in our class meeting, our second class meeting, this joint PDF f of x comma y equaling to, we had found it to be 1 over 32, 2x plus y, and that's if 0 is less than x is less than 3y is less than 6, and 0 otherwise. Okay, that's what we have. And we were trying to partially find the joint CDF of x and y, which we will denote by f of a of b. And what that's equal to, let's not forget, that's equal to the integral from minus infinity to b minus infinity to a of f of x comma y dx dy, which is representing the probability that x is less than or equal to a and y is less than or equal to b. That's what we're trying to find. And so we're integrating this joint PDF. And what we see is the joint PDF is often 0. It's often 0. Where isn't it 0? It's not 0 over this region of the xy plane. So here, let's talk about the region where the PDFs, so f of x comma y, the joint PDF, is non-zero. So pictorially, here's what it looks like. Well, the x values run from 0 to 6. The y values, well, 3y has to be between 0 and 6. That means y has to be between 0 and 2. And then we have this line, x equal to 3y or y equal to x over 3. And when x was 6, that would give us y being 2. And when x is 0, y would be 0. It's this line. And it turns out the region in this rectangle, we have two regions formed by this dotted line, y equal to x over 3, has an upper and lower part. And if you check a point in each one of these regions, you'll find out this is the region that satisfies this inequality. So here's what we're integrating over where the f of x comma y is non-zero. The first thing I want to notice that I said accurately in class was if A, which represents x values, for our joint CDF, is less than 0, you're talking about this region of the plane. If B, which represents y value, is less than 0, you're talking about this part of the plane, the lower half, the left-hand half. If either one of those happens when you're doing your integration, then what you're integrating over does what you're integrating, the f of x comma y, will be 0 because it won't include this region. Okay? And so we'll make that comment. So if A is less than 0 or B is less than 0, this is what we're looking at. This part is where A is less than 0. This part is where B is less than 0. The f of AB, the joint CDF, will be equal to 0. We're not going to do all of the calculations for the joint CDF. We're just going to do partial of it to explain how to do the integration of two variables better than what I did. Now, we're working on the case where, considering A, and so this is what I call case 1. That's fine. Case 2 has to do with, well, this is the region, this is 2 and this is 6. This is the region where f of x comma y, the joint PDF, is non-zero. And so what if A is between 0 and 2? So, sorry, it shouldn't have been 2, it should have been 6. So that was a mistake I think I had listed before. So this is an A, maybe.
Okay, now we can talk about b's. And we know if b is less than 0, it doesn't, the joint CDF is going to be 0. So we've got to be talking about b's maybe in between 0 and 2. But if we take this particular b right here, and we draw, that horizontal line y for b, its intersection with this region where f of x comma y, the joint PDF is non-zero, is this triangle. But if my b was right here, it would be this trapezoidal shape. And so that lends me to think that we're going to have two different, or at least two different cases. Actually, there's going to be three. But there's going to be some subcases for when a is between 0 and 6 due to the picture that we have. So here for the subcase 1, what if b is sandwiched in between 0 and, well, we want to make sure that the picture that's formed is this triangle. And so here, well, this point right here, which the b could run up to and still form a triangle, this point right here is the a value is a, the y value, remember we have x equal to, this line is x equal to 3y, so the y value would be equal to a over 3. So that's what the b could run up to. Maybe less than, something like that. It could be less than or equal to. Either way, it's okay. Okay. I failed to move this. I'm sorry. Well, let's go back here and look. So what we had said was case 1, I'm very sorry. Case 1 was where a is less than 0, b is less than 0. That's here over, here down. It doesn't include this region of integration. And so the joint CDF will be integrating 0 because that's what f of x comma y, little x comma y is over these regions. So we just get 0 for that integral. If the a value, so we're working on a, if the a value is big or in between 0 and 6, something like this, then we are going to get some region where the joint PDF is non-zero involved. And so we start considering b values. I'm going over again. If we take a b value like here, what we get is a triangle. If I take a b value like here, what we get, the region in here becomes a trapezoid. Okay? And so because we have these two different types of shape, that means we're going to have to split up the b value, what it is. What I said was we're going to get a triangle up to this point. What is that point? Well, the a value, I'm sorry, the x value is a. The y value, since x is equal to 3y, the y value is going to be a over 3. So as long as b is less than or equal to a over 3, we're going to get this triangle-shaped region. Let's talk about that. Okay, so if we end up doing the order of integration, so I hope everybody understands. I'm looking at something like this. This is my picture. It's this triangle. Okay? I'm integrating some function above that triangle, just over that triangle. So here's what we do. We have these two intervals. What I'm integrating is 1 over 32, 2x plus y, because the rest of the area is 0. Where are the limits of integration for the part where it's non-zero, the joint PDF? Well, what we said is, look at y. What do the y values run from? They run from here to here. B is up higher, maybe. Okay. Well, that is the B value at this point. It's the B value. I'm sorry, it's not up higher. That is the B value. So we say, what do the y values run from? They run from 0 to b. Now, what do the x values run from? Okay, so for a fixed y value in between 0 and b, okay, here the x values are going to run from 0 to that line. That's 0 to, okay, what is this line? This is x equal to 3y. I want to solve for x. It is solved for. So that's 3y. That's what we need to integrate. Let us go ahead and do this integral and see what we have. Okay? Okay. And whatever we get for this answer, it better be the same answer when I integrate over this same region, but I do dy dx. What is this? This integral from 0 to 2. I think of the inner integral and just calculate it based on integrating with respect to x. Here, I'm going to pull out the 1 over 32 out of both integrals. It's a constant. And here I have the integral of 2x plus y dx. That's going to be 2x squared over 2, so x squared, plus y is a constant, times x. By the fundamental theorem of calculus, I need to evaluate that from 0 to 3y, and then whatever I get, I integrate that with respect to y. Okay, so when we have 1 over 32, I stick in the 3y for x. We've got an interval from 0 to b. Okay. This will be 9y squared plus, here this will be 3y times y, so 3y squared dy. I can simplify that. When I simplify it, that becomes 1 over 32 times the integral from 0 to b of 12y squared dy. That's equal to 1 over 32 times the 12y to the third divided by 3. That's 4y to the third. Evaluate from 0 to b. When I stick in b, I get 1 over 32 times 4b to the third. That's the way I'm going to leave my answer. Okay. Now looking at the same picture, here's 6, here's 2, here's the x equal to 3y, here's the b. Let me make this up. Here's the a. Here, let me make the b look like this. Make this triangle, it's not above. Let us try to do the limits of integration in the other form, okay? So here, or, okay, we're going to have a double integral. It's going to be 1 over 32, 2x plus y. Now, what if we wrote down dy dx? So the thing I've got to consider is, this is a, don't forget that. For this region, what is the smallest a value? I need to put things here. The smallest, x value. The smallest x value is 0. And for any point in here, what's the biggest a value? What happens here? I don't know what a value that is, but I can tell you what the b value, what the y value is. It's b. Remember, this is the line. X equal to 3, 1. So if y is equal to b, x has to be 3b. So that part of what I said in class was accurate. But now, what does for a fixed x, what do the y values run from? Well, let's look at that fixed x. For any fixed x that I make, the y values are going to run from this bottom line, which in terms of y is x over 3, up to this top line, which is b. So I didn't write that down correctly in class, so this should have x over 3. Now we should get the same answer as what we got before, which is this 1 over 32 times 4 times b to the third. Let's take a look at it. This is going to be equal to, okay, integral from 0, I'm going to pull out the 1 over 32. 0 to 3b. Here, I'm integrating with respect to y, so I get 2xy plus y squared over 2. I want to evaluate that from y running from b, this is a y value. b to y equaling x over 3, and dx. Okay, so we stick in 4y, those particular values using fundamental theorem of calculus. When I stick in those limits of integration, we still have the 1 over 32. Here, this is going to be 2 integral from 0 to 3b. Okay, so here it will be 2xb plus b squared over 2 minus whatever I get when I stick in y equal to x over 3. That would be 2x squared over 3 minus, and now it's going to be, I think, x squared over 18 dx. We can simplify that just a little bit. So it's 1 over 32, integral from 0 to 3b Here, this is 2xb plus b squared over 2 minus, this is going to be getting a common denominator of 18. This would be, have to multiply this by 6, this is 12, this is going to be minus 13x squared, dx. Okay, that's what we are. Okay, now I'm integrating with respect to x, so this becomes 1 over 32. Here, this x squared over 2 is the antiderivative with the b and the 2. The 2 in the top and the 2 in the bottom are going to cancel. I'm going to be left with x squared b. Plus, this is going to be b squared times x over 2 minus, this is going to be 13x to the third over 18 times 3. And so that's going to be 54. And I need to stick in 0 and 3b. This is equal to 1 over 32. Here I'm sticking in 4x 3b, so this becomes 3b squared, that's 9b squared, that's 9b cubed. Okay. Here I stick in 3b, I get plus 3b cubed over 2. Here this becomes minus 13 times 27b cubed over 54. And when you stick in 0, you get nothing. So you don't have to subtract it. Well, we're almost done. That's equal to 1 over 32. This is 9b cubed plus 3b cubed over 2. And then here, the 27 and the 54 cancel with each other to leave a 2 in the bottom. So it's minus 13b cubed over 2. The 3b cubed minus the 13b cubed, each one of them over 2, leaves a minus 10b cubed over 2, so that's a minus 5. So it ends up being 1 over 32, 9b cubed, minus 5b cubed, and sure enough, that's 1 over 32, 4b cubed, which is what we had previously. So they give the same answers. As I said in class, there are times in mathematics where if you switch the order of integration, you do not get the same answer. But due to characteristics that the PDF has, the joint PDFs, we're never going to find a situation for probability where that occurs. Okay, so we can always switch the order of integration. Okay, that's good. I'd like to do just a little bit more for that CDF, just a little bit. One more situation. So remember, we were working with the subcase, we were working with the case that the A value was between 0 and 6. So here, so remember, 0 is less than A is less than 6. Here was our picture. So here was maybe 6, here's 2. This was the region of integration. Here's A. And I said, well, what if B is up here? So this is subcase 2. This was case 2. This is subcase 2. Now remember, we did the B being less than the A over 3, so that gave us a triangle. But what if our B was up here? So subcase 2 is where A over 3, excuse me, is less than or equal to B, which is less than, let's say, 2. I'm going to write it. So we're looking at this trapezoidal region. Now, I'm going to try to integrate our joint PDF over this region both ways, with respect to dx dy and dy dx. Two cases. Both times we get the same answer. That's just it. I'm doing this to illustrate how we do this integration. Okay. 1 over 32 is what I'm going to be integrating. 2x plus y. We're going to write down dx, dy for a second. Okay. So here's what I'm thinking. Well, what can the y values run from? They run from 0 to b. And for each fixed y value here, the x values run from this line, 0, to this line. That's 3y. But wait a minute, for this particular y value, the x values will run from 0 to a. So that prompts me to break up the integral from 0 to b. Okay, that's what the y values would run from, into two regions. So I'm going to integrate it from 0 to where we would have the triangle, because that would affect what the x values run from. That was a over 3. Okay? And then for those regions, a over 3, so really I'm looking at the function over this triangle plus the function over this rectangle. Okay? So here from any y value I pick in between 0 to a over 3, the x values for that particular y value will run from 0 to this line, which is 3y, plus, now I've got to get this region here, it would be that y values run from a over 3 to b, that's b, and for those y values, the x values will run from 0 up to a. And we're adding these together. Okay, so I got to do both of these intervals. So in this way, it's a little tougher to do dx, dy, because we've got two double intervals, but we can do them. So 0 to a over 3 for the first interval. I'm going to pull out the 1 over 32. Pull out the 1 over 32. Okay. All right, so that's where we are. And then here, this is going to be, with respect to x, it's going to be x squared plus y. X is the antiderivative. Evaluate that from 0 to 3y. And then whatever I get, I integrate that with respect to y. Plus here, it's from a over 3 to b. I pull out the 1 over 32 here as well. Again, I'm integrating with respect to x, so it's x squared plus yx. I need to evaluate that from 0 to a. And then here, this is dy. So here, this is 1 over 32. When I remember, it's x values, be 3y. Still integrating from 0 to a over 3. Those are the y values. Here's 9y squared plus 3y dy plus, from 1 over 32. Here, this is going to be sticking in a. So it's an integral from a over 3 up to b. Here this will be a squared plus ay dy. Okay, I made a mistake. Here when I let x be 3y, I get 3y squared. Correction. Okay, that's equal to 1 over 32. This is the interval from 0 to a over 3. This was 12y squared plus, here I can start on this interval. I'm doing it with respect to what? It's a squared times y plus ay squared over 2. I stick in a over 3 up to b. This needed a dy. This is equal to 1 over 32. Here, when I integrate with respect to y, I'm going to get 12y to the third over 3. That's 4y to the third. I need to stick in 0 and a over 3. Okay, plus. I would like to check something, so give me a second so I can look at my notes. Yes, everything's okay. plus, I think it's okay, 1 over 32. Here, when I let y be b, I'd have a squared b plus a over b squared over 2 minus, when I let y be 3, this will be a to the third over 3 minus, here I will get a to the third, when I square, remember I'm squaring this here for y, so it's a squared times a, that's a to the third. And then the 3 in the bottom being squared, so that's 9 times 2, that's 18. It's visible. Here, this is 1 over 32. Here, this will be 4 a to the third over 27 plus, I'm going to take out this 1/3 here. This will be a squared b plus ab squared over 2. Here, this is going to be minus, the common denominator here is 18, so let's see, this would be 6, it would be minus 7a to the third over 18. These two guys are like terms, so let's combine them. So it's 1 over 32, I think the common denominator is 54, so this will be 8a to the third over 54, and then this will be minus, and I think that's 3 times this guy, so it'll be minus 21 a to the third over 54, and this is plus a squared b plus ab squared over 2, and finally, it's 1 over 32 times that. We end up getting 1 over 32, and 8 minus 21 is going to be minus 13. So here I'll write down a squared b plus ab squared over 2, and then minus 13a cubed over 54. That's what we get. Now let's try to do the integral instead of dx dy, dy dx. It's much easier in this case. So I'm going to leave some of the work that I had up here on the previous panel. Just a little bit of it up. Well, just a little bit. This is what the case is. Okay. So we're looking at this subcase. Again, our picture is this. Okay. So here's our A, here's our B. And now, if I integrate instead of dx dy to get integrate the joint PDF, which is 1 over 32, 2x plus y over this region. dy dx, okay. So I say, what do the x values run from in this region? Well, the x values run from the smallest is 0. Here's where I'm writing down for the first interval, 0. The biggest value is a. For a fixed x value in this region, this one, what do the y values run from? They will all, no matter what x value I pick, all the y values will run from this curve, which was x over 3, if you solve for y, up to b. And let's see what we get. Only one integral is needed in this situation, so that, in a sense, is easier. Only one double. So this would be I'll take out the 1 over 32. Integral from 0 to a of here, this would be, if I integrate with respect to y, it would be 2xy plus y squared over 2. I need to evaluate that from y running from x over 3 to y equaling b, and then whatever I get, I integrate with respect to x. This is going to be equal to 1 over 32. Okay. Here, when I let y be b, so we have an integral still to do, 0 to a. Y is equal to b, so we get 2xb plus b squared over 2 minus whatever I get when I stick in y equal to x over 3. So this will be 2x squared over 3, I believe. And then it's x squared over 3. And then here, this will be minus, it will be x squared over, the 3 is being squared, so that's 9, so it will be in the bottom, makes 18. And then we have dx. I'm going to leave the answer that we got from the previous way of working the problem on the board here at the bottom so that we can compare it, because we're almost through. So where we were, we have 1 over 32. Now I'm in bring respect to x, so this will be x squared b plus b squared x over 2 minus, it would be 2x to the third over 9, and then minus, it would be x to the third over 54. We want to evaluate that from 0 to a. This is 1 over 32. Here this would be a squared b plus b squared a over 2 minus 2a cubed over 9 minus a cubed over 54. And then when you stick in 0, you get nothing. Each term has an x. So that's 1 over 32 here. This is going to be a squared b plus b squared, or ab squared, if you will, over 2. Here this is minus, in the common denominator, 54. Don't have to mess with this guy. But this guy, you have to multiply by 6, multiply the top by 6. So this is minus 12 minus 1. It's minus 13, a cubed. Okay. Ladies and gentlemen, those two answers are the same. So I hope this clarifies the mistake that I made and better explains how we switch the order of integration, how do we come up with the limits on the double integral when we're doing integration over a region in the xy plane. And I apologize very much for not answering Chris's question very well last time. I hope this is better. Thank you very much.